Okay, we've done well so far in the fact that we started off and we've drawn particles on the screen, but really we want them to animate. So I'm going to take a look at this function animate now. It's being called down here, so what's going to happen in my program, it sets the width and the height of the canvas, then it runs the initialization routine which sets up the particles and then updates them on the screen, and all that does at the moment is just draw them. But we're going to change this. We want more than draw, we want them to move. But first of all I need to define animation, and this is a loop. We keep looping round, but the problem is that it's not a while loop or a for loop as we've seen in Python. This is under the control of sort of Java and the browser. We have no control of this loop whatsoever. All we can do is say that we need an animation frame. Okay, that would be time frame or what have you. And what we're going to do in that is just keep calling this over and over again, and that's setting up a loop. So we request an animation frame and we say which function do we need to keep finding it from. And what we do when we animate is on each new frame we need to move the ball a little bit. So if I save that and run it, nothing will happen. We've got animation, but nothing is actually happening. So we need to move the ball. In other words, we need to update its position. And if you remember, we've got X and Y here. They're the two things that we're going to change, this X and this Y. But I'm only going to move the X direction at the moment. So let's take a look at how we do that. So it's this X, because it belongs to the particle, is going to be whatever it was before. So this X value, so if it was 5 here, it's going to be 5, and then I'm going to add 1 to it. So it's going to go really, really slowly. However, we're just defining how it's updated. We're not actually updating it at the moment. So if I refresh the page, you'll see, oh, it jumped across 1, but that was it. What we really need to do is, in the animation loop, is update the particles. And at the moment, I've got 4 particles, so I could probably just do p1.update. So each time through the loop, just update particle 1. So let's go see what happens when we do that. So refresh the page, and there we go, particle 1 is updating. We've got animation. Not brilliant, and as you notice, it's just going to go on forever, and it's leaving a nice solid blue line. In other words, it's not really erasing itself and redrawing itself, it's just drawing from where it started. So that's not too good. Let's change the Y value. So instead of this X, do this dot Y and see what happens there. You may be able to guess what happens. So if I save that and run it, what's going to happen with the particle? And there we go, it goes down. But notice as the value goes up, because we're adding 1 each time, the direction is down. It's opposite to the way a graph would work in maths. Y values tend to go up on axes, but in a computer screen, as they go further down, so the Y value gets larger. And that's going to be something that's going to be an issue at certain times for us to deal with. If I wanted to go diagonal, this is the important part, if I set both X and Y value, it will go diagonal. So I'm going to copy that from there, paste it in there, and change that to this dot X. So I'm changing the X value by 1, I'm changing the Y value by 1, save it, and refresh. And this time we've got it going diagonal. Let's take a look at this one. Let's say that I reduce the Y value by 1 instead of increasing it. What happens then? It goes up. And I can do the same with the X. If I subtract 1 from it, it's going to go to the left, not to the right. So we've got some way of expressing how we can move our ball on the screen just by changing its X and Y value, either by a positive or negative value. At the moment I've only got one particle moving. What I really want is all particles moving, and we're going to notice a small problem when I do it. So let's just copy this, and we've got 4 particles, so let's do it for all 4 particles and just change the number. And let's see if you can spot what the several problems are, but this problem, and that is they all whiz off in the same direction. They all do the same thing. So really I want a little bit of randomness coming in there, here somewhere. So if I set these to positive numbers again, and I'm going to go down and to the right. But they're really leaving trails, and I don't want those trails. So I'm going to fix that as the last part of this video, and then move on and work out how we can sort of randomize all of these things and make them all different. So the trails are created because when we request a new frame to draw on, we don't clear away what was on the previous one. So we need to erase things. Again, look at the video where I explain how animation works. And that is just a case of, well, it's the context, and we need clear rect. You'll find that again in W3 schools, and it needs, so what it's saying is rub out the screen, but it needs the coordinates of the screen. And if you remember, we have the top left hand corner is X is 0, Y is 0, and the width is not the inner width, it's the width of the canvas. So if I call that canvas dot width, and if you want to know a little bit more about rectangles, take a look at drawing rectangles in W3 schools. Whoops, talking some writing. So it's canvas dot height. So what I'm saying is from 0, 0 to canvas width, canvas height, down to here, clear the rectangle, okay, erase it, then update it. So if we get this right, what we should see is that the balls will not leave trails, and that they will actually move. There we go. But we have the problem that they're all moving in the same direction, and actually they go off screen. Not too good. I want them to hit this and bounce off in different directions. So we've got a fair amount of work to do on our update and the maths that's involved. And this is where it starts getting a little bit trickier to do, but we have drawn things and we made them move. That's pretty good. Maybe you want to try it with yourself, see if you can figure out how to randomize things, see if you can change the shape, maybe make them rectangles. Up to you what you do. But at the moment we've sort of come to the end of the first section. The next one we're going to start looking at the maths and trying to work out how to make things stay on the screen and bounce around.